Hello everyone, am I audible?
Yes, sir.
Okay. So we were doing collard greens. Just a minute. Yes, so we were solving variable separable form and we were on word problems. So let's start with this 20th problem. Have you guys solved it? Were you able to solve it? First of all, page 397, question number 20. In a bank, principal increases continuously at the rate of R% per year. Okay, so principal keeps on increasing.
Sir,
Yes.
we don't have word problems.
Okay, you guys don't have word problems in the syllabus.
Yes, sir.
In any of the, subsequent exercise as well, homogeneous and linear differential equations.
No, sir, we don't have word problems from this chapter.
Okay, cool. In that case, we just need to understand the two other types of differential equation, homogeneous and linear differential equations, and we'll be given directly an equation and then we have to solve it. So the first kind was, so we had this basic differential equation, first of all, first order, first derivative, which was dy by dx is equals to f of x comma y, where dy by dx was representing that this is a differential equation and fx comma y will determine the type of D, right? Now in the first case, this fxy was a function of the kind gx into hy. So basically, you can make a function of whole of x and a function of y, right? You can divide this into two independent functions, one of which is from y, x, and one is from y, right? So this was variable separable. In the case of homogeneous differential equation, if you replace x and y with lambda x and lambda y. So let's understand this first before this. So let's say I have this some function f of x comma y, which is x square plus y square, right? Now, what I'm doing is I'm replacing x with lambda x and y with lambda y. So in place of x, I'll use lambda x, and in place of y, I will use lambda y. Then this function is, wherever x is involved, we will change it to lambda x, and wherever y is involved, we will change it to lambda y, right? So f of lambda x comma lambda y is equals to, it becomes lambda x whole square, right? It was x square before, but after interchanging x with lambda x, after replacing x with lambda x and y with lambda y, it becomes lambda x whole square plus lambda y whole square, right? Now, what I can do is I can simplify it further. I can take lambda square common, and this becomes lambda square into original function x square plus y square, right? So any function which is of this kind, that if you replace x with lambda x and y with lambda y, that is basically what you're doing here is you're transforming your variable, right? Transformation of variable. So if you transform your variable to another linear function, right, your whole function becomes the lambda to the power something into that original function, right? So you can write it as lambda square into f of x comma y. So if you replace x with lambda x and y with lambda y in some function, and it becomes something kind of this, then this is homogeneous function. So basically what does homogeneous means is homogeneous is same, right? Same species is considered as homogeneous. So here the power of all the variables will be same. Power of whatever variables are involved in this equation will be same always. So that means homogeneous equation. Now this is homogeneous equation of degree 2. Why degree 2? Whatever the power of lambda is involved, that is the degree. Degree of homogeneous D. Right? So whenever we have any function of the kind f of x comma y, right? F of x comma y, and it becomes, so what we can write is in the second part, this was an example. Just write this as an example. Now the proper definition is a function fx comma y is considered, is said to be homogeneous of degree n, if after replacing, that is changing x to lambda x and y to lambda y, the function becomes something of this kind. You can obtain your original function back with total lambda outside, right? You don't have lambda inside the function. So you get your original function back if you replace x with lambda x and y with lambda y. And whatever power you have in the, or whatever power of lambda you have is called the degree. So this was of degree 2 because we got lambda square, right? Now what we are dealing here with this, sorry, shouldn't write this. Write this as degree of homogeneous function. Guys, have you written this? Can I remove this?
Yes.
Okay, so this was a homogeneous function. Now let's check some of the functions, whether they are homogeneous or not. Or rather, let's have this question. Define degree of the following homogeneous T. Oh, sorry, homogeneous function. Not homogeneous differential equation. We are just talking about homogeneous function. So first is f of x, y is equals to x square plus y plus xy. Second is f of x comma y is equals to x plus y square plus 2xy. Let's solve first these three. Yeah, so change x to lambda x and y to lambda y in the first equation. What did you get? Can you take out all of the lambda common? Just this is the most important factor. That when you change x with lambda x and y with lambda y, whether you are able to take all the lambda common or not. So I'm just replacing everything, x with lambda x. So this becomes lambda x whole square plus y with lambda y plus x with lambda x again and y with lambda y, right? So this becomes lambda square x square plus lambda y plus lambda square x, right? If I want to take lambda common, I can only take lambda, right? Not lambda square. So I am left with lambda times of x square plus y plus lambda of xy. Now see, I can't take all of the lambda common. And why is this happening? Because see, here the power of y was 1 only. It was not a homogeneous function because all of the powers involved are not same. See, the power here is even 1 and 1. But on multiplying, this becomes 2, right? So while writing degree, we will consider it as 2, not as 1, right? So this x square plus y plus xy is not a homogeneous function because of this y, right? Similarly, in this case, second case, is this function a homogeneous function?
No, sir.
Why?
The degree of x is 1.
Degree of x is 1, right? So both of these are not even homogeneous functions. So how can we define the degree? Not a homogeneous function. Similarly, now in this case, can you first tell me if it is a homogeneous function or not?
Yes, sir.
Okay, and in that case, if it is a homogeneous function, what is the degree?
2, sir.
Yeah, correct. So in every term, you can see that the power of variable is 2 only. Hence, it is a homogeneous function and the degree is 2. You can do that even without checking, right? But you have to show it. If asked, you have to show it. Now, can you check this function as well? X square plus y square divided by x square minus y square. Yes, guys, is this a homogeneous function?
Yes, sir.
And the degrees?
2.
In the fourth part, degrees 2. Okay, so let's check once. Replace x with lambda x and y with lambda y, and then check.
Sir,
Is there a
degree.
change in the answer? Yeah.
Yes, sir. 0.
Yeah, degree is 0, correct. So it is a homogeneous function, but see, lambda square cancels out because it is present in the numerator as well as in denominator. Hence the expression remains same. Expression remains same if you replace x with lambda x and y with lambda y. See, lambda square is common, it becomes x square plus y square, and then lambda square is common from the denominator as well. This becomes x square minus y square, and it cancels out. So you got the same function, right? If there is no lambda involved, you can write it as lambda to the power 0, because lambda to the power 0 is 1. Hence, this is homogeneous with degree 0. Homogeneous with degree 0. Now let's start what we have started to do. Homogeneous differential equation. So we now know that what is a homogeneous function, right? A homogeneous function is that function if you replace x with lambda x and y with lambda y, you get the original function back. There is some power of lambda involved, right? Whatever that power of lambda is, that is the degree of that homogeneous function. Now, if we talk about homogeneous differential equations are a kind of differential equation in which this f of x comma y is a homogeneous function of degree 0. Let's understand this. Can I remove this? Okay. So homogeneous differential equation. Homogeneous differential equation says that a differential equation of the form dy by dx is equals to f of x comma y, where f of x comma y is a homogeneous function of degree 0. If this function involved is a homogeneous function whose degree is 0, in that case, this differential equation will be a homogeneous differential equation. Now let's start. How can we solve it? What is a homogeneous function of degree 0? How will it look like? So see, first of all, to have degree 0 and a homogeneous equation, now understand some of the examples first. Let's understand some homogeneous function of degree 0, right? So let's say I'm writing x plus y. Now I know the degree is 1 right now, because we have one lambda common if we replace x with lambda x and y with lambda y. So I have whatever power is involved for x and y, that should be same for numerator and denominator. I should have both numerator and denominator, then only we can cancel out, right? So I have to take any variable in the denominator. So it can be of any type. But if let's say I'm using y square, in that case, the equation is not homogeneous, because the numerator as well as the denominator both should be homogeneous, right? And should be of same degree. So in this case, the numerator is homogeneous, but the denominator is not. Now, the numerator is also homogeneous and the denominator is also homogeneous. But in this case, tell me whether this will make a homogeneous differential equation or not. Is this a homogeneous differential equation? If I write an expression like x plus y upon x square minus y square is equals to dy by dx, is this a homogeneous differential equation?
No, sir.
And why is that?
Because the degree in the numerator is 1 and the denominator is 2, which is not equal.
Yes. So hence the final degree of this differential equation would not be 0. It would be -1, right? So this will not be a homogeneous differential equation again. This will not make the cut, right? Now, if I do this, in this case, this is a homogeneous differential equation. So this function is a homogeneous function of degree 0. Hence, we have to find out any function which is this of this kind. So we can also use the degree 2 in both numerator and denominator. We can also use the degree 3. We can use anything, but the degree of numerator and denominator must be same. Now let's understand these type of expressions once. If I divide this whole expression, if I divide the numerator and denominator of this whole expression by x square, what would it look like? It would look like it would look something like this. X square plus y square divided by x square, right? I'm dividing the numerator with x square and I'm dividing the denominator with x square as well. X square minus y square divided by x square. Now see, I'm doing the same operation both on numerator and denominator, so I can definitely do that. This becomes 1 plus y square by x square whole divided by 1 minus y square by x square. I could have divided this whole by y square as well. Just a minute, guys. Yes, so I could have divided it whole, numerator and denominator by y square as well. In that case also, the expression is going to be the same. Not same exactly, but what I'm telling you is something different. See, I can make this function as 1 plus y by x whole square and 1 minus y by x whole square. So now this whole equation is in the form of y by x. If I replace y by x with some other variable v, let's say this y by x is v. So I'm left with 1 plus v square divided by 1 minus v square. So what we have done is all of these kind of homogeneous function of degree 0 can be merged into one variable only. That is the best part. You can always reduce their variability. That is why they are called homogeneous. So what we are doing is we are taking this form of function. Every homogeneous function actually looks like something this. They can be converted into y by x form or x by y form, any of that. Hence, to solve these kind of homogeneous differential equation, to solve homogeneous differential equation, what we do is we have a set procedure. You have to follow these two steps. Can I remove this? Good. So these type of functions will sometimes, either sometimes they will be given directly in the form of y by x, or sometimes we will have to check first that whether the given differential equation is homogeneous or not. Only then we will be able to proceed. So what we will have to do is we will have to convert them into y by x or x by y form. So these two turns out, similarly, either you will be given this form dy by dx is equals to some function which has to be converted into the form of y by x. Or sometimes the equation can also be given as dx by dy. In spite of dy by dx, you would be provided dx by dy, and then your function would be in the form of x by y. Right? You have to make these two things. First, substitute. These are the two most important steps. You have to substitute y by x with v. So basically, you have to substitute y is equals to vx. And then after that, you have to also make a substitution for dy by dx. Because you are removing y by x, or you are removing y and x, or you are removing y, definitely y, right? So you will have to remove dy by dx again. Now to do that, you have to use this equation again, this result. You have to differentiate this equation with respect to x. If you differentiate with respect to x, what did you get? What will you get? Dy by dx, right? In the left hand side, dy by dx. Then you have to apply product rule to solve vx. While applying product rule, this would become, first, let's take v common, I mean v as it is, and the differentiation of x would be 1 plus x as it is, v is dv by dx. Now just remember, v is also a variable. You are trying to, I mean, replace a variable, right? So a variable will be replaced only with another variable. Hence the product rule. Hence you have to apply the product rule. Otherwise, if v would have been constant, the differentiation would be v only, right? Vx is v, but v is also a variable. So you'll have to apply product rule on this. So Vx would be V into 1 plus X into dV by dx. Hence you have to apply these two substitutions to solve. Use them in the original equation or original homogeneous T to solve using variable separable form. So this variable separable form is the easiest one. I mean, that should be the standard method of how to solve a differential equation. But because of we are not able to, I mean, convert all the x with dx and all the y with dy, the homogeneous concept arose. In this case also, you have to apply the same things. You just have to replace y by x with x by y. So in this case, x by y would be v, means that x would be vy. So this is one important substitution. Then you'll have to differentiate it with respect to y. In that case, this becomes dx by dy is equals to v plus y into dv by dx, right? So these two are the important substitutions in case of dx by dy, and these two for dy by dx, right? Now let's solve a problem to understand it better. But this was all the theory involved. The questions are pretty easy, not to worry about. Let's come to the page number 406. Let's start with question number 1. Can I remove this? If somebody is writing, just raise your hand. Okay. So we have start with question number 1 only. X square plus xy into dy is equals to x square plus y square into dx. Right? So x square plus xy into dy is equals to x square plus y square into dx. Right? Now we can either check directly. See, the power of x is 2 here. Again, the power of variable is 2. 1 plus 1. Power is 2. Power is 2. Right? So in all of the 4 terms involved, other than dy and dx, right? In all of the other 4 terms involved, the power is 2. Right? Hence, this is a homogeneous differential equation. But you should always confirm it, and you can do that by just rearranging the terms. So this would become dy by dx is equals to x square plus y square divided by x square plus xy. Right? And now you can observe this, the degree of numerator is 2, right? So degree of numerator is 2, right? And just a minute, guys. So the degree of numerator is 2 and degree of denominator is 2 as well. Degree of numerator as well as degree of denominator, both are 2. Hence this equation is a homogeneous differential equation. So the first step, just check whether the given equation is a homogeneous differential equation, right? And in this case, now after checking this, let's substitute whatever the substitution we have to use. So the substitution was y by x with v. So basically y is equals to vx, you can write it directly. Y is equals to vx, and so let's write it properly first. Substitute y with vx, differentiating with respect to x, we get dy by dx is equals to v plus x into dv by dx, right? Hence the given equation will become v plus x into dv by dx. In the place of dy by dx, we will use second equation. In place of dy by dx, we can write v plus x into dv by dx is equals to x square will remain x square plus y square will become v into x whole square divided by x square plus x into vx. So in place of y, I have replaced it with vx, and in place of dy by dx, I have replaced it with v plus x into dv by dx, right? Now, what we can do is we can take x square common from the denominator and numerator both. So this becomes v plus x into dv by dx is equals to x square into 1 plus v square divided by x square into 1 plus v. This x square would cancel out. This v can be taken into the right hand side. So this becomes x into dv by dx is equals to 1 plus v square divided by 1 plus v minus v. So this v can be written as v by 1. Now we have to apply basic difference of fractions. This becomes 1 plus v square. This becomes v into 1 plus v divided by 1 plus v into 1, which is 1 plus v only. Right? So this is x into dv by dx is equals to 1 plus v square minus v square, right? Divided by 1 plus v. Just note this down and understand it properly. Okay? I mean, just you just have to replace these two things, and after that, just apply the simplification properly. You'll get the answer. You know how to solve it. Now, I mean, after the point of substitution, everything is under control. Yeah, guys, can I remove this? Okay. So this becomes, this v square will get cancelled out with v square. This is x into dv by dx. X into dv by dx is equals to 1 minus v divided by 1 plus v. Right? Now this can be separated out with dv. All of the function of v can be rearranged with dv and all of x with dx, right? So this would become 1 plus v divided by 1 minus v. I have cross multiplied it with dv, and dx would become this, right? Now how to integrate it? It can be written as 1 by 1 minus v into dv plus this would become, okay, so 1 plus v can be converted into the form of 1 minus v, right? This would become, take minus common. If you take minus common, you can easily convert it in the form of 1 minus 1. And take minus common, so it would become minus y minus v minus 1. After that, minus v plus 1. So just add and subtract 1. So this would be minus of minus v plus 1. This would become minus 2, minus of minus 2 plus 2. Now, why I'm doing this is minus v plus 1 is 1 minus v, right? Plus 2 divided by 1 minus v into dv. We know why we are writing this, right? Take log c as. So this would be minus, when we divide them, it becomes minus 1. And this becomes plus 2 upon 1 minus v into dv is equals to log of cx. This becomes, when we multiply minus 1 with dv, this becomes minus of v when we integrate it. And this becomes 2 into log of 1 minus v divided by minus 1 is equals to log cx. This was the concept we have already learned. These concepts, I mean, this is just the method of integration, right? Now we can further simplify it because we didn't have v variable in the starting, because we have replaced it. That is why we have to get the answer in the form of x and y only. But I will simplify it to the point I can. This can be further simplified. So this becomes minus y, and this is minus 2, which can be written as plus 2 if I take it to the right hand side. Log of 1 minus v plus log of cx, right? So this becomes minus v. This 2 becomes 1 minus v whole square, right? I can take this 2 to the power of 1 minus v. And this would be log of 1 minus v square into cx. Okay, this is log a plus log b. Now, what I can do is, I can write this expression as 1 minus v square into cx is equals to e to the power minus v. Now, replacing back v as y by x, this becomes 1 minus y square by x square into cx is equals to e to the power minus y by x. This is the final answer. I mean, this should be. You can also write it in other ways, but I mean, you can leave it. But always simplify to the point you can. And always remember this, that you have to put back the value of v. Right? Now let's practice this once or twice. You'll get it easily. Not something to worry about, but yes, you have to definitely do it to understand better. So let's start with second question. Second one is this: y dash is equals to x plus y divided by x. What I will do before solving the question, I would write it as 1 plus y upon x, because in that way this would be much easier to solve the question, right? This y dash is equals to 1 plus y by x, right? You know what are these two substitutions? Just apply them and try to solve them. Anji, कहाँ तक पहुंचे? I mean, sorry, where did he reach? Is this equation a homogeneous differential equation? First of all, in place of y dash, I'm writing dy by dx. Now, is this a homogeneous differential equation? Yeah, Z, I didn't listen to you. Is this homogeneous differential? No. Now, this is a homogeneous differential equation. Because if you replace y with lambda y and x with lambda x, so in that case, this would lambda would get cancelled out, right? You won't have any lambda if you replace x and y with lambda x and lambda y. So this is definitely a homogeneous differential equation. Remember this, you'll have to always check this. There should be no lambda involved in the equation if you replace x with lambda x and y with lambda y. So just check all the powers and check whether the powers are present in numerator and denominator both. Okay. And the power should be same. So this is a homogeneous D. So now we know we have to replace, and the homogeneous D is in the form of dy by dx. See, so we have to replace y with vx and dy by dx with v plus x into dv by dx. Apply them, you would get v plus x into dv by dx is equals to 1 plus. From this, you get y by x as v. Now this v gets cancelled out with another v. So very simple equation. See, x into dv by dx is equals to 1. So this becomes dv is equals to dx by x, which is v is equals to log x plus log c. Always take log c in place I mean, in spite of c, just take log c. You'll get the answer easily. I mean, the solution calculations will be easier. That is why I'm taking log c every time, because every time you'll get log x in the answer. I mean, most of the times, not every time, but yeah, most of the times you'll get log x. So whenever the x is in log x form, in homogeneous D, I'm only talking about homogeneous D right now. Whenever you get log x, always take log c as the constant rather than c. In that case, you'll be easily, I mean, you'll be able to easily solve the equation. So you get v is equals to log of cx. Now you get cx is equals to e to the power b, right? In place of v, we can use, so this is cx is equals to e to the power y by x. That is the answer. That is the solution of this given D. Let's solve fifth. 5th, 6th, and 7th. We'll solve these 3 questions, 5th, 6th, and 7th. You guys have to solve this. You have 5 minutes. Let's start solving them. I need first answer. I mean the answer of question number 5th within 3 minutes. Okay. And please post your doubt, whatever doubt you're having. Just ask, okay, or raise your hand. Solve it quickly. If we are able to solve it quickly, then we can also move on to linear differential equation today. Because the concept is done. You just now have to do the practice part. So take your time, ask your doubts, and solve these 3 questions. Yeah, guys. 5th, able to solve it. Is this a differential homogeneous differential equation, first of all?
Yes.
Okay. And what is the substitution? Is it y by x or x by y?
Y by X.
Y by x. We can use either one, but I mean, generally in case of availability, if we are if they have given dy by dx in the question, in all of such cases, just use y by x as well. So replace y by x with v and dy by dx with v plus x into dv by dx. Am I correct, guys? Is the equation correct?
Yes, sir.
And the integration of 1 minus 2, 1 upon 1 minus 2, 2v square is? What is the formula for this? This is of the form of, can you just tell me what is the form? Dx by
1 by a square minus b square.
x square. This is a square minus x square, which would become what?
1 by 2a.
Yes.
Log a plus b a plus x by a minus x.
Just use the same formula. This is 1 by 2. Now this will become 2 root 2. Can you explain me what is this? Why is this extra root 2 here? See, because we got 1 minus root 2v into 1 plus root 2v. So in place of v, in place of x square, we got 2x square. Hence the root 2 of x whole square. So x is now replaced with root 2x, which will be divided, in which case we will divide the whole answer by root 2. Hence this root 2 becomes. And this will be equal to log x plus log c. So this is nothing but 1 minus root 2 divided by 1 plus root 2 to the whole power 1 by 2 root 2 is equals to cx. This v can be, this will become y minus root 2x divided by y plus root 2x to the whole power 1 by 2 root 2 is equals to cx. We could have written it in another form as well. This is also the correct form. In place of y, I can write this as 1 by 2 root 2 log of y minus root 2x divided by y plus root 2x is equals to log of cx. This can be given in either form. Or there may be any other expression as well, but all of them are correct. Just replace v with y by x in the final answer. First, form this v using the substitution and then replace back v with whatever the substitution is. Yeah, sixth. Can someone confirm if sixth is a homogeneous D or not?
Yes, sir. It is
Yes,
a homogeneous equation.
But the powers used are x square and y square, no? And at one place it's x and y. Let's make the correct form. What is the value of dy by dx? Tell me, what is the value of dy by dx?
So under root x square plus y by x.
Yeah, correct. So can I remove this? If somebody is writing, just raise your hand. Okay. So in the sixth question, first of all, I'm writing this into the correct form, which is I've taken y into dx to the right hand side because I have to combine dx together, right? And I got x into dy is equals to y plus root over x square plus y square into dx. Hence, dy by dx is this function, y plus root over x square plus y square divided by x. Oh, sorry, not x square, it's only x. Yeah, so I was asking you guys that we have x square and y square and also x and y. So how can this be a homogeneous function?
When we are substituting x square, lambda square x square and lambda square y square, when you take that common and square, you'll get lambda outside.
Yeah,
So
so
it
we have
cancels.
also, yeah, right. So we also have a square root, right? So because of the square root, whatever the power of lambda we get outside is 1. So this can also be written as y by x, right? Now we can take this x inside the square root. If I take inside square root, I will square it. If I take outside, I'll have to take power 1 by 2. So I'll square it. This becomes x square when it goes inside the square root. So this is 1 plus, because x square by x square is 1, plus y square by x square. This becomes the value of dy by dx. Now, if you replace y with vx, again, these two replacements, if you do that, you get this expression. Just a minute. So we get v plus x into dv by dx, right? Which is the value of dy by dx is equals to v plus root over 1 plus v square. Now this v gets cancelled out with another v, and this is, we are left with x into dv by dx is equals to root over 1 plus v square, because this is 0, nothing but 0. Right? So in this case, x dv by root over 1 plus v square into dx by x. Now if we integrate, what is the left hand side? If we integrate dv by root over 1 plus v square, this is right hand side is the same, log x plus log c. But what's the answer for left hand side? dv by root over 1 plus v square.
Log v plus root of 1 plus v square.
Correct. So log of v, I'm writing v directly now. Log of v. Okay, let's write v only. Log of v plus root over 1 plus v square is equals to log of x plus log of c. So this becomes log of, I mean, I can make, right hand side can be solved further. This log x plus log c can be written as log cx. In that case, log will cancel out. I mean, not log will cancel out, but both the expressions are inside log, and both of the logs are equal. That is why the inside expression should also be equal. So hence I can write this v plus root over 1 plus v square is equals to log of cx, which is cx only. So in place of v, I'm writing back the expression, which is y by x plus y by x whole square. That is your final answer. Sixth part. Are you guys able to solve 7th? See, this is also a direct identification for homogeneous DE. If you see any expression in which you are given directly y by x or x by y, so in 7th, we are given cos of y by x and sine of y by x. Then again, in the right hand side, sine of y by x and cos of y by x. So as soon as you spot this expression, y by x or x by y, be sure that this is a differential, homogeneous differential equation. So whenever any of this kind of differential equation is given, in which you are directly given with the expression either y by x or x by y, that equation must be homogeneous D. So in 7th, what you can do is you can start it directly. Just take dx into the right hand side. Okay. Divide all of the expression with x and take dx into the right hand side. If you do that, can you tell me what is the expression? If I divide left hand side and right hand side by x and also take dx into the right hand side, I'm left with, yes, what's the expression? This becomes cos of y by x, right? Because I have divided the whole expression by x. So this becomes y by x. Am I correct? This is sine of y by x into y is as it is. I'm taking dx into right hand side. So this becomes dy by dx. Now this is y by x into sine of y by x minus cos of y by x. So after dividing, you can write this before the start. After dividing by x square, after dividing by x. Now dy by dx is cos of y by x plus y by x sine of y by x into y okay, we are also given x here, divided by y by x of sine of y by x minus cos of y by x into x. Just replace directly. So we have cos v plus v sine v divided by v sine v minus cos v into y by x is v. Take v into the right hand side. This becomes x into dv by dx is equals to v cos v plus v square sine v divided by v sine v minus cos v, and this v goes to right hand side as minus v. Now this is x into dv by dx is equals to v cos v plus v square sine v divided by v sine v minus cos v. This gets multiplied, v square sine v plus v cos v. This gets cancelled out. So this is x into dv by dx is equals to 2v cos v divided by v sine v minus cos v. This is nothing but v sine v minus cos v divided by 2v cos v into dv is equals to dx by x. So this is tan v by 2 minus 1 by 2v into dv is equals to dx by x. So this becomes 1 by 2. Differentiation of tan v is? Yes. What is the differentiation of tan v?
Log
Log sec v minus 1 by 2 into log of v is equals to log of x plus log of c. This 1 by 2 can be taken common and can be shifted to right hand side. So this becomes log of sec v minus log v. This becomes log of a by b, which is log of sec v upon v is equals to twice of log cx. This 2 goes here. We can further simplify it. Let's just write it here. Write it up to this point, and you can further simplify this. Find out the final answer. After the class, not right now. But let's first understand all the basic part. We just have to we need to apply these two substitutions. If we know them, we are good to go in this case. So you should know what a homogeneous D is and then how to solve it using the two substitution. So all of the three parts are simple only. You just have to identify what is a variable separable form. Variable separable is when you can directly separate all of the variable. All the x with x, dx, all the y with dy. If you can't do that, then you'll have two choices. One of them will be homogeneous DE, which we have just completed. In case of homogeneous DE, you will not be able to separate out the variables directly, just as in you were doing in variable separable form. You will not be do that directly. But what you can do is you can apply these two substitutions. And after these substitutions, the form will become variable separable only. See, at this point, this is variable separable at this point. Because you can take all of the v with dv and all of the x with dx. So what homogeneous D is doing, basically changing your known variable separable form to variable separable form. Okay, so can we further move? Has everybody written? Just
Yes.
raise your hand if you haven't. Okay. Now we haven't talked about linear differential equations, first of all. So any differential equation is called linear. Okay. If the power of, okay, so this is a0 plus a1 d of n minus 1 into y. Just stop writing first. Just understand this, because this is not the point, because what I'm telling you is the basic part. This you don't have to understand thoroughly. You will not be solving many questions on this, but this is basic linear differential equation. Now we will discuss about what is in your syllabus, but first let's understand what is a linear differential equation. So what I'm doing is I'm taking nth derivative equation, nth order equation. This is nth order, this is n minus 1th order. N can be anything. If I take n5, so this will be a fifth order equation. And fifth order, fourth order, third order. Obviously, this will be called as fifth order, but there are other orders involved as well. Fourth order, third order, right? If I take n as 5. They may or may not be involved, but the highest order involved is something called n, right? In this case. This is a linear differential equation where a0, a1, A2 an are either constants or function of x. So what we are saying is that first of all, any equation is a linear differential equation if the power of any order is not greater than 1. You can check nth order is also having power 1, n minus 1th order, n minus 2th order. In fact, dy by dx, first order, the power of every expression, every derivative is 1 here. So these are the important points. Power of every derivative must be 1. Power should not be greater than 1. Because if the power is greater than 1, then this equation is not linear. We have already, we are studying linear equations from class 9th. We know what does linear mean. Linear means power 1, right? So how the power can be changed? Either through derivative or should be no term containing the multiplication of containing the product of, we can write that, containing the product of y with its any derivative. So y should not be multiplied with any of the derivative. That is why I've written a0, a1, a2 up to an. All of these coefficients must be either constants or functions of x. They should not contain y. So any of these coefficients, they can either contain x. I mean, this can be a function of x. This can be a constant, but this cannot be a function of y. So first is power of every derivative must be 1. Second is should be no term containing the product of y with its any derivative. That is, there should be no y into dy by dx or y into d2y by dx square, right? And third is power of y must be 1. In all, if an equation satisfies this, that is called a linear differential equation. For an example, this equation 3x d3y upon dx cube plus 2 d2y by dx square plus dy by dx is equals to x into y. This equation is definitely a linear differential equation. Hence, any such equation in which the power of every derivative is 1. See, the power is 1 in every case. There is no term containing y into, let's say, if I have this 3xy into d3y upon dx cube. In that case, this is not a linear differential equation because we have a term containing product of y with its derivative, right? But here we got no term containing y with, containing the product of y with its any derivative, and the power of y is also 1. So let's say if I have this equation, x into y square, this is not an LDE. So I'll use LDE, short form for linear differential equation, LDE. So any such equation is LDE. This is the basic differentiation, basic definition of linear differential equation. Now we'll talk about what's in the syllabus. We can't contain these terms, higher order derivatives terms. We only have first order, first degree in our syllabus. That is why all the LDE, all the linear differential equations that we are going to use will only be of first order. And if we have a first order LDE, we can easily define that. Now how? I'll show you. This can also be written as a into n plus 1. So if we have first order LD, in that case, all of this part will be removed. Because first order derivative means the highest order derivative is dy by dx. All of the term containing d2y by dx square or d3y by dx cube or y4, y5, anything, any higher order derivative will be 0. Because we have first order, first degree differential equations only in our syllabus. Yeah, guys, can we proceed?
Yes, sir.
Okay, so we have LDE of first order. So LDE of first order can be written as dy by dx plus py is equals to q. See, this is the same form, same exact form. What we are saying is, we're saying that always take the coefficient of dy by dx as 1. I mean, in this case, you'll be able to simplify your equation better. So if any such equation is present, that dy by dx plus p into y is equals to q, where p and q, again, this is important again, where p and q are either constants, they can have any constant value, or a function of x, where p and q are either constant or a function of x, is called the equation of the form dy by dx plus py is equals to q, where p and q are either constants or a function of x, is called LDE, linear differential equation of first order. Some of the examples are dy by dx plus x into y is equals to cos x, or dy by dx plus 1 by x into y is equals to tan x. And these are the examples. You can easily observe that highest order is first. There is no term containing y into dy by dx. The power of y is also 1. Now, how to solve them? Procedure to solve them. This is again, if you remember, homogeneous D. Homogeneous D was, we had a set procedure to solve homogeneous D. In the same way, we have a set procedure to solve LDE. What is, you have to understand these two things again, 2 steps. First, find integration factor, IF. What is IF? IF is e to the power integration of p dx. IF is integration e to the power integration p dx. And second step is solution of the given d's. In the second step, you're reaching directly to the solution. Solution of given differential equation is y into integration factor y, whatever, I mean, y, the dependent variable in your original equation, y into integrating factor is equals to q into integrating factor. Now you know what is y and what is, I mean, what is p and what is q. P is used to find out the integration factor, and then this integration factor, integrating factor, integration, not integration, it should be integrating factor. Integration factor is this integrating factor. Integrating factor. So q into integrating factor into dx plus c. So this is, this is the final solution. You just have to integrate this part and get the solution. Let's understand through one question what is the procedure. Very easy, not anything to worry about. Let's solve question number first in the given exercise 9.6, page number 413. Can I remove this? If you haven't written, just raise your hand. Okay. In this case, we got dy by dx plus 2y is equals to sine x. So first of all, we have to identify what is the value of p and what is the value of q. So p here is 2, the coefficient of y, and q here is sine x. See, the coefficient of dy by dx is 1. First, identify whether the coefficient of dy by dx is 1 or not. If not, then make it 1. After that, calculate p and q. In this case, it is easier because it's the first question. So we got 1 as the coefficient of dy by dx. We got p as 2 and q as sine x. First, find out integrating factor. So integrating factor if would be e to the power p into dx. We got p as 2. So this becomes e to the power 2x. Okay. My bad, guys. Sorry. Let's change the question. In this case only, because we will take much time actually to solve this question. It will take time. So p here is 1 by x. In this case, p is 1 by x, right? And q is x squared. Just so in this case, we got p as 1 by x and q as x squared. So if is e to the power 1 by x into dx. Now the integration of 1 by x is log x, right? This becomes e to the power log x. Now we can further simplify e to the power log x. If you simplify e to the power log x, in this case we have x, because they both can be interchanged, e and x. So this becomes x only. So your integrating factor is x in this case. Now the final solution is y into integrating factor is equals to q into integrating factor into dx plus c. So this becomes y into integrating factor is x is equals to q is x squared. Integrating factor is x. This becomes y into x is equals to x cubed dx plus c. So this becomes x to the power 4 by 4 plus c. The final answer is your general solution for the given differential equation is y is equals to x cubed by 4 plus c by x. That is how you can solve linear differential equations. You can start solving homogeneous, complete all the homogeneous. I think tomorrow will be holiday because we have Christmas. Merry Christmas, guys, by the way. And we'll we'll continue this in the next class. So you can start with homogeneous and try to complete linear differential equations as well. We will discuss the doubts and miscellaneous exercise. go through all of this once and ask me your doubts. We'll practice some of linear differential equations in the next class as well. Then we'll finish this chapter and move on to the next one in the next class only. 12th can leave the class, and 11th guys, we'll start this within 2-3 minutes. Just wait for 2-3 minutes. Yeah,
Thank you, sir.
sure.
Thank you, sir.